Of course, we are not. Hey, period 5. Speaking out to period 2. All right. We are not happy with a conceptual understanding. We need to do mathematical explorations of how light bends, so that when you are given the piece of plastic, you can measure the angles, the incident rays, and the refracted rays, and apply Snell's law to accurately predict the path that the light will take. So here is Snell's law of refraction. N1 sine theta 1 is equal to N2 sine theta 2. That's Snell's law. Now, why am I using 1 and 2 instead of I and R? Because people get confused when it's going from multiple in and out materials. Is it incident or refracted? So we'll just say 1 and 2. You're going to have to put this on too. I don't think I give you space in this packet to write these notes. So you may want to put this in a notebook. I would suggest. So again, N represents index of refraction. Theta is the angle relative to what?
Normal.
Relative to the normal. Always, always, always relative to the normal. If you measure this relative to the surface, it's going to get messed up. All right, this experimental discovery was made by Wilbur Snell, which is why it's called Snell's law. All right, so if it goes from air into glass, it's going to what? Slow down or speed up? It's going to slow down, so it's going to bend towards the normal. All right. So here's an actual example. An incident ray that's at 30 degrees. Air, N is equal to 1. Glass, N is equal to 1.52. So the question is, what is the angle of the refracted ray? What is the value of this angle right here? Gee, Mr. Parker, I don't know what to do. This is really hard. There's a lot of variables. If only I could identify them all. Oh, yes. List your variables. That's a great idea. We're going to list out our variables. Theta 1's 30 degrees. Theta 2, that's the one we're looking for. N1's 1. N2, 1.25. What formula will you use? Snell's law. N1 sine theta 1. N2 sine theta 2. Now, this is where it gets really strange, because you got to solve this equation for the angle. So the first thing I do is I'm going to divide both sides by N2. I'm going to get rid of the N2 from this side to get sine theta by itself. Sine theta 2 is equal to N1 divided by N2 times sine theta 1. Anybody happen to know how to get theta by itself? You take the inverse of the sine. On your calculator, there is an inverse sine function. Usually you have to hit second and then inverse sine. I'll show that on the overhead in a minute. But if you take the inverse sine of both sides, you get theta 2 by itself. If you plug that into your calculator, you should get 19.2 degrees. All right, so I'll put it on the overhead, and I'll show you on the calculator. Hopefully you're following along in your notes, writing this stuff down like the diligent students that you are. Of course you are. Or you could do that. Yeah. All right. So our equation was theta 2 is equal to N1 over N2. People are going to have to remind me. Oops. Did that wrong. I know, sorry. Is equal to the inverse sine theta minus 1 of N1 over N2 times sine theta 1. So if I put the numbers in, could people remind me what the numbers are? What was N1? 1. What was N2? 1.52. And the angle? Sine 30 degrees. Okay, so that's what it looks like. We'll put it into our calculator. Second sine. Second sine, 1 divided by 1.52 multiplied by the sine of 30 degrees. And that's all you have to do. You have to make sure that your calculator is in degree mode. If it's in radian mode, you will get a different answer. Alright, and that's all there is to it. Peace out.